Hi, I'm Byungjin Chun from Northwestern University. It's a great honor to introduce our work and pub your mobile web experience here. Web browsing has been a core part of our daily life, brushing our teeth, right? So now, however, most of web pages has been designed primarily for the desktop on wired network to say the best configuration. So this disconnect has served as like motivation for both industrial and academic research and development. Among the industrial work, few has been more controversial and at the same time interesting than Google's project AMP. AMP is announced October 2016, and 3 years later now is everywhere. If you use MobiCom, then you must have seen this before. There, in the search result page, there's a small lightning sign, which is an indication of the AMP page. And also the search result page sometimes brings up the dedicated AMP carousel, which has multiple AMP pages. If you click one of them, then you will be redirected to the AMP page, which is distinguished by the AMP bar located on top of it. This AMP bar has been a bit of controversy because, as you see, I don't know, like you can clearly see that the AMP bar at the address bar doesn't clearly reveal the original source. It seems like it's from Google. There's more controversy. AMP strictly restricts the format of the contents. So this is against content provider's goal. And I think that the second point comes from the fact that the Google is the leading company of the web search market. If Google prioritizes AMP over the other page in either direct or indirect way, then the content providers will be forced to use this AMP without, regardless their preference. So like so many controversy seemingly, then why people use this? Because it's surprisingly fast. Let's take a look how fast it is. So left one is AMP page and right one is non-AMP page for the same version, for the same page. So as you see, AMP is way faster than non-AMP version. So in our study, we focused on this, the performance benefit of AMP as a first academic research about it. There are lists of techniques for AMP, from the simplification of the page to like dedicated caching and pre-rendering. Our question is there any dominant feature out of this? In other words, is this possible? Just this is big because this is Google, or this can be a kind of general solution for network performance on mobile? To answer our question, we collect AMP pages in the wild. Since there's no known list of the page, we collect 3,400 AMP pages using Google's trendy keywords. For these pages, we found that some of them has its non-AMP version, but not every page has its non-AMP version, so we filtered out those pages. After that, we ended up with 2,100 AMP pages. We test these pages using web page test, which is like powerful web testing tool with a separate router for emulating the mobile network condition. This first plot shows an anecdotal report on AMP's performance benefit. As you see, the performance jump is drastic, and we found that more than 90% of AMP page is faster than its non-AMP counterparts. So again, what is the dominant feature? To separate the potential contributing factors, we use different versions of AMP pages. AMP has 3 different versions: AMP Original, AMP Cache, and AMP Pure. AMP Original is page generated and hosted by content provider. This page is cached and validated by AMP CDN. This version is called AMP Cache. But AMP Cache is not directly served to user. There's one more version, AMP Viewer, which is a wrapper page for AMP Cache. So the final version user will see is the AMP viewer page containing the AMP's cache page. So these three versions let us isolate more or less the contributing factors to performance. Let's take a look at more one by one. First, AMP original present a simplified and restructured version of the page, non-AMP page. So it has no custom JavaScript except for AMP runtime JavaScript, which is asynchronously and kind of collectively working for different AMP pages. Also, it enables lazy loading, which loads only important objects at the moment of page loading. And there are like a bunch of different techniques about this, but let's take into account as a whole. The second thing is AMP cache. AMP cache primarily does three jobs in terms of performance. The first thing is cache. It cached the AMP original page in its globally distributed CDN, its dedicated CDN. The second thing is validation. This validation is important because if the validation fails, the page will not be served to user. It guarantees the user will always see perfectly performing AMP pages. The third one is AMP viewer, which is primarily for pre-rendering. In the Google search result page, an AMP page is pre-rendered if there is at least an AMP page in the first viewport of the search result page. This is done automatically, so if you visit the pre-rendered page, then you will enjoy almost zero delay. However, in this graph, we don't consider the impact of the pre-rendering. We're going to talk about later. As this graph shows, the performance gap between AMP and non-AMP page is huge, and still, the performance gap between AMP versions are pretty small. And as you see, the biggest jump comes from seemingly AMP original, which is simplified version of page. So we wonder how simplified it is. And it turned out to be pretty much simplified. This CDF shows the number of images loaded in different versions of the AMP in its initial loading. As you might see, non-AMP version has 4 times more images than its AMP version, and difference between AMP versions are almost negligible. The other major type of object shows similar trends, and we think this implies huge impact of format restriction of AMP, because page rendering, page loading time, is affected by the number of objects almost directly. To answer our initial question, so what is the dominant feature of the AMP's performance benefit, we measure the performance jump for each version of AMP page from the previous version. So from non-AMP to AMP original. AMP original version introduced page format restriction, introduced 6,000 milliseconds of performance improvement in median. But AMP cache just introduced 260 milliseconds. So in terms of performance, AMP format restriction plays a much important role for AMP performance benefit. However, we haven't discussed about one important aspect of AMP, which is pre-rendering. As pre-rendering introduced zero delay, almost zero delay, instant loading, one can expect pre-rendering would introduce huge impact in terms of performance. And that is true. AMP pre-rendering introduced almost 2 seconds in median of performance benefit, performance jump. AMP pre-rendering has more aspect and diverse stuff, interesting stuff. But as we don't have enough time, we are not going to discuss about this more. So for more detail, please take a look at our paper. Nevertheless, I need to mention at least one thing. There's no free lunch. AMP's pre-rendering always comes along with its cost. on 1.4 megabytes of data usage on average per web search. So this means if you don't visit the pre-rendered page, the additional cost data usage is going to be for nothing. To recap, AMP has like clear performance benefit at the cost of uniform look, losing some dynamicity, and some data usage for pre-rendering. This leads us our next question. How much of existing web can they take advantage of AMP's format restriction without going through Google's pipeline? Thank you for listening. Any easy question is welcome.